Okay, so hopefully that was like a reasonable lead in to my hypertonic, hypotonic, isotonic discussion. All right, away we go. So first, before we get to that, let's go ahead and talk about diffusion. So diffusion is when molecules move from an area of high concentration to an area of lower concentration. They want to be equal on both sides of the membrane. So the thing is, some molecules can move through pores, and some are too big to get through the pores, so they have to use protein channels. This is called facilitated diffusion. The thing about diffusion, though, is it doesn't take any energy. So it doesn't take any ATP. It's just moving from an area of higher concentration to an area of lower concentration. And that's true of diffusion as well as facilitated diffusion. Neither use ATP to get through. It's still moving from an area of higher concentration to lower concentration. Looks a lot like this. All right, so let's go ahead and determine the difference between what a solution is and what a solute is. Basically, a solute is what will dissolve in the solution. So, for instance, in salt water, the solute is the NaCl and the solution is the water. So the salt is going to dissolve in the water. All right, so let's jump in. This is what happens when you have a hypotonic solution. What that means is there's more solution than there is solute. So in this case, you're going to have more water than NaCl outside the cell, okay, in the solution. So the water is going to want to flow toward the NaCl. In this case, the solute is the NaCl that's inside the cell. So you can see here that there's more solute, there's more salt inside the cell than there is outside, and so the water is going to want to flow into the cell. Now again, to remember, there's going to be flow back and forth, but the majority of it is going to be flowing into the cell. And also, since the water molecules are a lot smaller, it is a lot easier for them to get through than it is the NaCl, the salt molecules. This will cause the cell to expand, which is known as cytolysis, and it actually may pop. Hypertonic solution. So this is when you have more solute, in this case NaCl, than in the solution of water. So the water is going to want to flow from inside the cell to the outside the cell. So if you look here, there's more salt on the outside, so the water is going to want to flow from inside the cell into the hypertonic solution. This is going to cause the cell to shrivel, otherwise known as plasmolysis. Lastly, isotonic solution. So an isotonic solution is when you have equal amounts of solute and solution. So the cell is going to stay constant. So it's not going to change shape. But again, remember, it's not like there's nothing moving in, nothing moving out. There is going to be salt moving in and water moving out and vice versa. But there's just an equal amount going in and going out. So the cell overall is going to stay constant. So let's go ahead and bounce on over. I've got another way of explaining it, and we'll see you in a minute. Okay, so let's have a closer look at what happens when you put the cells in different types of solution. Now, what's important to remember is that what we're talking about here is the state of the solution that the cells are being placed in. All right, so let's go ahead and have a look at what happens when you have there you go. We have a hypotonic, where you place a cell in a hypotonic solution. So what you've got is you have more salt inside the cell than you do outside the cell. Now it's important to remember that you've got a semi-permeable solution. So you've got, the salt and the water is going to be able to go pretty easily into the cell and out of the cell. And also it's important to remember that salt loves water. And vice versa. They want to hang out, they totally want to bond. So what's going to happen then is, since there is more salt inside the cell than in the solution, is the water, since it can move much more easily through the selectively permeable membrane, the water is going to flow more into the cell. Now remember, there is water and salt flowing into and out of, but the net movement of the water is going to be into the cell because it wants to hang out with the NaCl because, well, it loves it. So let's go ahead and look at the next state. So here we have a hypertonic cell. So what happens here, or excuse me, you have a cell that's placed in a hypertonic solution. So what's happening here is just the opposite, is you've got more water inside the cell than the solution outside. So what's going to happen here is that there's going to be a net flow out of the cell. Because again, the water can flow more easily through the membrane, and it wants to hang out with that NaCl. There's not much blocking it, so it's going to just go ahead and boogie right out here. So again, there's going to be water and salt flowing into and out of the membrane, but overall, there's going to be a net water loss. So more is going to flow out than going to flow in. And lastly, we've got the isotonic solution. So an isotonic solution is when there's a roughly equal amount of salt and water on the outside to salt and water on the inside. So that state is basically going to be, there's going to be roughly the same amount flowing out as flowing in. And that's called dynamic equilibrium. All right, so let's go ahead and see what effect placing the cells in these different types of solutions have on the cells themselves. So let's go ahead and look at hypotonic. So what's going to happen with hypotonic is, since you have more of a net flow of water inside the cell from the solution, the cell is going to swell. It's a swell cell. So what's going to happen there is something called cytolysis. So cytolysis is when the cell swells actually to the point where it actually bursts. Let's go ahead and have a look at what happens when we have a hypertonic cell, or a cell placed in a hypertonic solution. So here what we've got is again, you've got a net movement of water out of the cell. So you've got flowing out of the cell. And what happens when you have a net movement of water out of the cell is the cell is going to shrink. And what that's called is something called plasmolysis. And then, of course, with an isotonic cell, since there's an equal amount of stuff flowing in and flowing out, is that cell is going to be very, very happy. Okay, Katya, so I hope that was helpful, and we'll see you all next time.